All right, should we get started? All right, I'll just start with an introduction from people that are still coming in. I think there are still people arriving. All right, well, I'm going to start with just some general rules that everyone should be aware of before we get started. So there's an automatic live transcript powered by Otter that we've posted into the YouTube live chat, if you would like to use that. For anyone who's watching over the YouTube, if there are any issues with the stream, please put it in the YouTube chat and we'll try and sort it out. If the stream goes down or something like that, just check your emails because we might send you a new stream link. So everyone who's in the alt space in the room, please make sure to mute yourself during the presentation. We'll try and mute everyone automatically, but if you could also try and make sure that you're muted, that will also help. So what we have in alt space is this spatial directive audio. So we won't be able to hear that through the live stream. You'll only be able to hear the people on the stage, we hope. But it's quite useful if you want to get together afterwards into groups and have like a chat or something. You can only hear the people that are near to you. So it's nice to have sort of like group discussions and stuff in the room. So we have a maximum of 50 people into the alt space. So I think we're under the 50 at the moment, so that's not a problem. But if we get more people, if we reach the maximum, then you'll have to watch over the live stream. You might notice as you come into the alt space that we have a poll as you come in. We'd really appreciate it if you could fill out that poll and let us know what you think. Give us some feedback on the format of the event and of the platform. That would be great. You might also notice that there are some interactive exhibits around as you come in. So there are some little exhibits about radio telescopes in the main forum that you can interact with. You could also try going into the JAXA room. This is a room that's set up with some interactive objects. You can kind of pick them up, look at them, throw them around, stuff like that. That's really fun. So that might be a nice thing to do after the talk, to go and take a look at that. So getting to the questions after the talk. If you're in alt space and you want to ask a question afterwards, you can just raise your hand. If you've got a VR headset, literally just raise your hand. But if you're on the laptop or something, there's a little emoticon emoji thing on the menu. If you just click that, there's a little option that allows you to raise your hand. So that's how it works if you're on a laptop. If you're on the YouTube, you just post your question into the YouTube chat. You can, and try and limit the YouTube chat just to the Q&A as much as possible, so we can try and follow what questions are being asked as we get along. There's a bit of a lag on the YouTube. It's somewhere between 10 and 30 seconds. So please be patient. There will be a bit of a delay before we can answer your question. Okay, so I think that's everything I need to say. Yeah, we'll just get to it then. So I'm going to introduce the speaker. So today our speaker is Dr. Vanessa Moss. She is an astronomer based at CSIRO, where she is she's head of the science operations for the Australian Square Kilometre Array Pathfinder, aka ASCAP. She also leads training for the Australia Telescope Compact Array, or ATCA. She's previously worked at Astron, where she was head of Aperative telescope operations for Westerbork, and also worked with LOFAR telescope operations. And in her research, she studies H1 absorption and emission in the Milky Way through to distant galaxies. And today she's going to talk to us about career paths in telescope operations. So take it away, Vanessa.
Cool. Thanks so much, Hannah. So I guess before I start, I'll just make sure that the audio is coming through okay. Um, if those with hands can kind of wave, or you have emojis actually, by the way. So if you want to emoji, you can do that. So I'm just gonna make sure I'm grabbing the laser pointer, correct? And I'm just gonna test that and see that people can see it. And I'll turn it off again. So yeah, let's get started. So firstly, thank you so much for being here today. It's really an interesting experience. This is one of, like, I have given a talk in VR before, but this is one of the first, like, kind of with a lot of audience, and it's really fun, and it's a different experience, right? Like, it's nice to have us together in the same virtual space. So I hope you enjoy it, and we're looking forward to hearing feedback on it. I also want to say thank you to the IAU Junior Working Group, so Hannah and Camillo and all of the members, for giving me the chance to speak to you today about observatory careers and what they could possibly mean for your personal career. So as Hannah said, I am Vanessa. I'm based at CSIRO in Australia. CSIRO itself, it's Australia, it's National Science Agency of Australia. Sites all across the country, but in astronomy specifically, so I'm part of space and astronomy. We're focused mostly on Sydney and Perth. Those are our two main hubs, and I am based in Sydney, part of CSIRO. So what I'm going to talk to you today is to give you an insight into what it looks like if we're thinking about observatory careers, and how it relates back to academia, which often is a lot of what we experience as students and postdocs, and give some examples based on what I've experienced through my career so far. So let's see if I can advance the slide. Uh, and a shout out to Wombo, which Wombo is an AI art making, and I used it to fill in some of to help me do some pretty pictures of things to illustrate where my talk was going. So that was quite a fun thing to do. So the first thing I wanted to start with was a journey to an observatory career. The important caveat to this, and I think it is quite important, is that, and you've probably realized this already, everyone's career path is different. There's no recipe for, do this, do this, do this, and it all works out. There are things you can do, there are things you can be thinking about throughout your career to sort of like head in certain directions, but every person you talk to is going to have a different take on this. So I want to point that out because the best way to learn about all of the options available to you as a junior astronomer is to really find out how other people around you have got to where they are today. So that's what I encourage you to do. And I obviously a lot of people in observatories and academia around the world, so I can point you in different directions too. And I'll give you my perspective on this based on what I experienced. So to start with, a very quick overview of my background. I'm not going to dwell on this too much because Hannah already covered a lot of it. I was based first at UC Sydney for both for my undergrad and for up until the end of the first postdoc, although throughout that time I changed different subjects, and we'll come back to that. I was based at Astron in the Netherlands for a couple of years and then came back to CSIRO, which is where I've been since then. Hannah mentioned that I oversee science operations for ASCAP and the complex array studio astronomer side. But other hats that I wear are the future of meetings. This started its life as a symposium. It's continued on as a community to explore better ways in how we interact and meet. And also, I am an exec member and currently one of the co-deputy chairs of the EMCR Forum in Australia. So this is dedicated to give out the challenges that face early and mid-career researchers, doing everything we can to help. So yeah, definitely reach out. Even if you're not in Australia, I think we're still really keen to hear challenges you might be thinking about. Also, and I can circulate these slides afterwards, but I put a link, like, if there's anything you want to reach out to me about, you can find me on Twitter on the junior member Slack as well. Okay, so to give you a bit of a background of what I did, my undergrad, so I did an undergraduate degree at the University of Sydney in liberal studies advanced. This was kind of arts and science, and I majored in physics and Japanese. Part of that, I spent 6 months in Tokyo on exchange. So that's the photo that you see here with a lot of people both international and based in Tokyo. That was really cool. My first kind of, I guess, academic experience was a meeting at the ASA in 2010, the National Australian Astronomy meeting where I presented a postdoc. So that was sort of where I would say I got into the astronomy side of things, serious way. And so to show a little bit of what I mentioned already, these are the different places that I was based at so far. And so I did honors at University of Sydney, and on an automated search for supernova remnants. I did a PhD focusing on Milky Way H1, or neutral hydrogen in the Milky Way. And I did a postdoc at the University of Sydney, but through CSIRO, which was a research centre. And that was focusing on what Hannah mentioned, which is atrial absorption in AGN and along the line of sight, and also commissioning observations with ASCAP. At Astron, it was working with LOFAR and Aperitif, and that was the first role where it was explicitly focused on telescope operations. That was a position that was 50% telescope operations and 50% research, and the research was quite flexible, but obviously the telescope operations was quite specific. So that was the first time I think where I went specifically away from the normal academic path of pure research. And then I came back to Australia in 2019 as a staffer in CSIRO to focus on ASCAP and compact array, and then other things since then as well. The reason I point this out is because I think when you look at it, maybe, I don't know, maybe it looks like it was planned. It wasn't planned at all. Things are really never planned. And I remember very vividly the chaos of not knowing, what am I going to do for my first postdoc? Where am I going to be next year and all of that? And I think that's a really huge challenge that faces early career researchers, is that instability. I hope that as a community we can do better. But what is there is, throughout that, I did have exposure to a lot of different telescope facilities and observation types, and that played a key role in sort of getting that breadth of knowledge of how observatories work and what kind of telescopes are out there, and how our skill sets as astronomy students and later postdocs can fit into that world. So I recommend, I guess, getting close to telescopes if you can. Like I say, that was, if I look back and say, okay, what was a key thing that sort of led me down this path? Australian community, we have a lot of radio astronomy, and as well as optical and other, but through the radio astronomy community, I was exposed to radio telescopes quite early on as an undergrad student, and I was able to work directly with them and observe directly with them. And I think that was one of the things that made a difference. I also wanted to mention, it could be a whole nother talk, talking about coding and Python or whatever language you prefer, how computing skills and data management skills also help you in a career in science. But just to briefly mention, I didn't come up through any computer science background, but I was introduced to coding and to Python through a project supervisor while I was an undergrad. And that was like a huge eye-opener, because suddenly it went from, okay, these are all these things to do manually, like with spreadsheets and documents. We can do so many more things when we start to think about how do we automate them and how do we do them systematically, being able to visualize your data. I think that was a really key factor. And I know, for me, it was a huge revelation as a student to find these are things you could do. I think we do a better job now introducing students early on to the amazing powers of coding. But I guess that is a key skill set that's very, very flexible in no matter what career you go down. The ability to problem solve and systematically or algorithmically approach things is a really important skill. And a bit of a shout out to the Practical Astronomy with Your Calculator book, which I found on a library shelf in the ATCA observing room. And yeah, that was really cool because it was written in originally the 80s. And so it really spells out exactly how you calculate things that you point your telescope at. Like, how do you convert current time to sidereal time and all of that? It spelled it out in approximations. That was really a good introduction to how we run observatories, get at a really low level. I know everyone's thinking about differences and our ability to meet in person. And I'll be the first to acknowledge that there is something you get from being together in person, like eating together, that's really valuable. I thought I'd reflect a little bit on which conferences did actually have a significant impact on the direction I took. These were things like the radio school in 2010. It was the first school I ever went to. It's where I met a lot of people who are now colleagues around the world working in astronomy or otherwise. And it's also where I learned some of the fundamental skills of radio astronomy. So I think that was really important. I was involved in astronomy. I encourage you to look it up if you're interested in web development and programming and using astronomy in data context and skills. That was really very impactful in terms of realizing that a whole community of people who really value these kind of things and do cool projects and all kinds of hackathon-y things with their skills. Another one to mention was RFI conference in 2016. This is a conference that, in astronomy, we think about radio frequency interference from microwaves and phones and Wi-Fi and all of that. Think of that as a problem and an interference. This was a conference focused on that, but also trying to work closely with the telecommunications people and try to link in with those communities, as well as the Earth satellite observation communities who get our impacts of RFI, even from space looking down at Earth. And so just connecting with these cross-disciplinary communities had a big impact as well. I think I pressed the wrong button. So that's anyway, that's a little bit about me, and feel free to ask me other questions later if I didn't cover something you had a question about. Now I want to go into the contemporary observatory and what it means, how it might be changing, and sort of give you an insight. So I thought I'd start with this. We're not actually going to play this game; it would take a while. But I encourage you all to have a look at this slide, it shows 10 telescopes that in the way you've either observed directly with them or used data from them in a project. There's more than this, but also covering a lot of different wavelengths. One of the main points I want to make with this while you're thinking about which ones of these you might recognize is not an expert in all of the observatories in the world. Worked at exactly 2. I've worked at CSIRO and I've worked at Astron. Those are the ones I know really well. They're obviously also radio astronomy observatories. I've observed with other telescopes. I haven't worked there. So I would encourage you as you go through this talk is to, that's the expertise I have, and I can talk a little bit about other wavelengths. But the best way to understand how those other places work, for example, ESO or ISA or NREO and places like that, is really just get in touch with people there. So I'll encourage everyone strongly, if you are interested in particular observatories or other wavelengths, or space telescope as well is a great place. Anyway, so hopefully you've had a little bit of a chance to look at some of these pictures and see if you recognize. Those are all the telescopes that are there. Yes, there's a little bit of an Australian bias, but I don't know. Hopefully I covered a fair number of wavelengths as well. One thing to mention also is Parkes telescope, which I've listed there as Muriang. That's actually the indigenous name that it was recently given, along with other telescopes on the site, and that's something I think it will be really cool to see more of around the world, is recognizing the locations in which we build our telescope. And I put the credits as well. Slide. I didn't put them on the previous slide because it would give it away. Okay, so those are a little bit of telescopes. What does working at an observatory look like, or what do we do at observatories? And so I put a couple of things that came to mind first, and I don't know, if we had more time and maybe we're in a slightly, or I don't know, standard platform, maybe I'd do a Menti poll or see what people are thinking, but you can all think it and just not tell me. So we've got here telescope operations and maintaining telescope hardware, or anything to do with telescope hardware. So those are probably, those are the 2 main ones I think people think about, but I'd be interested to know after the talk if you were thinking a different direction. But actually, working in observatory is a lot more complex than that, and there's a lot of other things. This is not in any way an exhaustive list, but like I mentioned already, cross-disciplinary teamwork, working with people in lots of different sciences and beyond science. Outreach and education, like science communication, is often a part of what we do at observatories. Tool and software development, so that's something that's really close to my heart because I love Python. This was trying to write a Python automated script to automatically pick a pointing pattern that runs on the telescope and helps us separate the position and the pointing of the telescope after it's been recalibrated. That's an example of things. And commissioning those, so trying to do new things with instruments or even design new instruments is as well. The image I have here, I'll come back to a little bit, but this was trying to capture some of the different processes that are part of observational radio astronomy. It used to be, I think, in the past when telescopes were simpler, that people would be across all of the different things you did as a radio astronomer, everything from conception of the instrument and building it all the way to pushing it and promoting it and that sort of thing. I think now what we see is people tend to narrow in a little bit. Actually, it's a really useful skill to have knowledge across all of those different sections. So like I said, we'll come back to it a little bit after. So what kind of people work at a radio observatory? So this is a photo I like because this was when we finished first pilot surveys for ASCAP, and we got together on a video call. to celebrate and watch the ending of the observations. So it was a bit stressful on my part as like the person saying, okay, is the telescope behave to the extent we can watch the ending, but luckily it did. But what's also really cool about this is that this is not all of the people involved in ASCAP in any way. It's a really nice cross section of different people have very different roles as part of the project, and all of these roles are really important. The point I wanted to make here is that like in and this is true I think in a university context as well, being at a university doesn't mean being a professor. Being at an observatory doesn't mean being a telescope observer, right? There's a lot more that goes on to make these institutes function. And so whatever your interests are, there's a lot of different ways in which you potentially contribute. And so Aiden might be cringing right now because he's like, oh no, not the structure plot. But this is I think it's a really great chart made by Aiden to show the structure of how the ASCAP project and the different teams and the different people fit together and how we work together. You don't have to know the details other than to recognize it is quite a complex thing. There are lots of different sections all the way from, the operation side of either the telescope observing or the data processing, trying to debug and understand issues. If we find an issue, maybe we have to go to the digital hardware team to figure out how we solve that issue. So this gives you an idea again of how complex just a single telescope can be. So an institute is so a lot more complex than that. But it again means there's a lot of different ways in which, as a member of that observatory, you can contribute. So what I wanted to show very quickly as the next part is some of the tools or the things that I've done. I mean, I've done a lot of different things throughout my observatory connected career. But here are some of the cool things or the things that I don't know, I'm quite proud of. So for example, this is this LOFAR map. This was a way to try and bring together a lot of different disparate information that we had about LOFAR to one visual place. So things like this basic stuff is where are the stations located across Europe, but also, if you dig into the layers in this map, you can see things like outliers or the temperature of cabinets or stuff like that. There's a layer that shows the network of connections across Europe. So if a particular network or intranet thing is down, this is I would say quite a basic thing. It could be a lot more than it is. It gives an idea of the kind of power of bringing data together. And that's something I think that the next generation of astronomers is a lot better at than me and the current generation or the previous generations, because you're just so used to data. Data is just everything we do now. So anyway, so you can check that out. That's still live, hopefully, and working okay. Another thing to mention, and this is more down the line of using telescopes in different interesting ways that we might not think about. One of the projects I worked on with LOFAR was near field imaging of RFI. And what you do here is when you radio astronomy, when you take a Fourier transform of the sky, you assume that you're Fourier transforming at infinity. But actually, you can take images all along the volume to infinity, and that means you can image the ground plane as well. And I'm oversimplifying it because it is honestly a little bit confusing to me and baffling that we can do this. But it means, you have all of these antennas and they are receiving signals from every direction if they are all sky antennas, like if they're omnidirectional in some way, which means that you are actually getting delays and signals from every direction, including the ground. If you have that separation and that spatial difference, that means you can start to pinpoint, okay, if I see an emission on the ground level, where is it coming from? In this case, we were able to, for example, locate RFI to the cabinet. There was something in the cabinet creating it, or RFI in a nearby building or stuff like that. Lawn mowers, electric fences. So I think this is a really cool thing. There are so many ways in which we can use telescopes in new, interesting ways in the future. And so that's something you can definitely do as part of being connected to an observatory is push the boundaries of what we can do with telescopes. I thought I'd quickly mention that we're currently looking at using similar techniques to try and characterize lightning with the MWA. It's pretty exciting and cool. And I'm looking forward to seeing how that goes. So this is a very complex slide. It's just I was kind of like, put all the things related to this onto one slide, which maybe was a mistake. But I think what I also wanted to show with this is how things like concepts apply across observatory. I have always been a fan of automating things that I feel like a computer can do better than me. If it's repetitive or if I'm liable to make mistakes, then I take that responsibility out of my hands and I trust something like a Python code. So that's where we think about, okay, well, we're used to scheduling telescopes and reacting and having the human in the loop there, but does that still make sense in the current times? So one of the ways that I've been exploring this with other people, both in Aptiv and ASCAP, is going from first from manual scheduling to then automated and now to autonomous. So with Aptiv, we went to automated where we could take pools of observations that needed to be done and then schedule them. And there was also work separately for the surveys that did similar stuff. And then you just provide that schedule and the telescope does it. But the next step is, okay, well, what if I want my scheduler to react to circumstances at the time, like weather or tennis falling out or things like that? And what if that's at 3 a.m. and I don't want to be up at that time, or I don't want to pay someone to be up at that time? And so that's where we sort of get onto this autonomous scheduling idea, where we're starting to have much trust in the system as we can, automate a lot of the steps and teach it how we would make decisions, not saying like in an intelligent way, just an algorithmic way. And then, that's how it performs compared with if we were humans in the loop as well. And we use the human expertise where it's most valuable. And so this chart down the bottom is showing where, so phase one for ASCAP observations was where we're sort of transitioning to automated, but we had a lot of stability issues. So this green dash line at the top shows our success rate, and that was a bit variable. Consolidation had a very high success because we didn't do a lot. We just improved the system. We did the first test of autonomous scheduling in a simplified pool in Christmas 2020. And you can see our efficiency and success rate was pretty high there. We went into a pre-phase two where we were still sort of preparing the surveys, and now we're in this phase two phase. We're trying to keep it as close to one as possible, but also assessing how this goes and how this sets us up for doing full surveys of the sky with ASCAP. So that's really exciting. I could talk a long time about that, but I will stop there. But just, these are some of the things, the questions that we think about in astronomy and in observations right now. Another one is to do with decision making about data quality. So again, this is one where it's connected to work I did at Aptiv and in Astron, trying to visualize raw data. I think in that sense, we kind of got away with the fact that Aptiv and ASCAP are both phased array feed telescopes, and now is a perfect time, and I should have done this sooner, to point out this amazing model behind me, which was made by Aidan. It's the CAD model of ASCAP, but made so much cooler with textures and details that he added. And so the coolest thing about Aptiv and ASCAP is the use of this new technology that gives us a much broader field of view of the sky. So the path that you might be able to see, I think it's off the live stream, but it's up here. That is a new kind of receiver that opens up that view. And only instead of seeing a single pixel, we see many, many pixels at once, which is great, but also more complicated. It makes for a lot more complex data than we used to, a lot more data as well. And so we're still in the process of figuring out, okay, how do we deal with this? We can't look at all the data. We want to look at it. We don't even want to look at a subset of it, really. We want to know, okay, so look at this and make decisions. But if we can look at it, can we teach a code also look at it and make decisions and just tell us what to do about it? So this plot on the right is an example from some early work that I've been doing using outlier detection, so autonomous semi-automated encoders. And it's looking at this data, doesn't know anything, but what it's just looking for is things that stand out. Anything with a box around it, it's decided is an outlier. This is a really, really kind of like bare bones way of doing it, but we can improve on it. And we're hoping that we can get to the stage where our raw data can be assessed by something like this. And we only step in where we need to. It can make most of the decisions about whether it's good or bad. So that's the thing that we're working on in ASCAP right now. So to go back to, I think, a little bit of the observatory side of things, and what it means to work in an observatory. I made this overwhelming slide full of text, don't worry. I'll get the slides to you somehow and you can actually read it. The idea with this slide is really just to show you that there's pros and there are cons. No environment, no job is ever perfect. And it really comes down to what you think is going to you best as, given interests and your skills. We'll come back to that. So these are some of the things, I guess, Things with asterisks, put asterisks because it can be true, it might not be. It really depends on the institute, it depends on the kind of position and the kind of work they're doing. I know people who are at observatories, but they also have teaching positions at universities, or they do teaching as part of that. So, like I said, it varies. I guess I'm trying to think if there's anything to point out. I mean, I guess things change over time. So I could mention this less visibility and credit. In academia, I think we're still sort of recovering from a bit of like hero complex in science, where we think it's not, science results are never done, very rarely done by a single person. It's usually big teams, and it's there's a lot of complexity around a new discovery, for example. But academia still has a lot more visibility. Like the research result has a lot more visibility, and all the steps that were taken to get there. And that's something we also see, for example, in coding. I think in the open source community, like AstroPi, it's sometimes been difficult for people to get all the credit for the immense amount of work that goes into building these packages, fundamental to how we do astronomy. I think that's getting better. I think it still has a long way to go. I feel like is an important thing to point out and to think about, because when we decide where we want our community to go in the future, to recognize that there's a whole lot of skills that go into making astronomy results happen. Anyway, so like I said, you can look at those a bit later with the full. In the SNA context, this is just to give you an insight of thinking about the future and what are some of the question marks for us. Things like have engineering labs. We also now have a really split balance between the east coast and the west coast of Australia. And that's relatively new to us. I think some institutes around the world have been dealing with this for a long time. But for a long time, a lot of activity in astronomy in CSIRO was focused in Sydney. So that and the telescope sites. But thinking about remote observing, how we train the next generation. I talked about remote management and automation with ASCAP, as well as the control of telescopes. Supercomputing, again, that's a whole nother field. I'm not going to go into detail, but encode data rather than bringing the data to your laptop, I think is something we're still adapting to as a broader astronomy community. And distributed machines is still in progress. For collaboration, I think is something that's at the forefront thanks to 2 years of interesting pandemic times, and thinking about how we go forward in the future. What do we want the future of work to look like versus the best parts of 2019, for example. So those are sort of some of the things that we think about. I'll very briefly mention I wrote a proceeding for the 2019, and I'm forgetting what year it is now. The 2019 AIDA meeting, which took place in the Netherlands, in fact, in Groningen. And in that, I tried to reflect on, having worked with telescopes, what were some of the key things that we needed to think about into the next generation. It's pretty short, it's like 4 pages, they limited it, and I actually really like that. I wish more papers were limited to just 4 pages or so. But anyway, you can check that out if you're interested to know more about that. So to touch a little bit on some of those key questions, or the big questions, is in 50 years' time, if we don't think about how the next generation of astronomers has the skills that people who built the telescopes by hand 50 years ago, how do we translate those skills and how do we pass on that knowledge? That's something that I think to think about a lot. How do we do it in increasingly equitable and sustainable ways? That's something that the pandemic sort of forced us to think about. But it's actually been, for all some of the negatives, there's actually been a lot of positives. And so that's a space I and others I know in this alt space room have been thinking about over the past couple of years, is how we take the best of what we found over the last 2 years and move forward with that and make that part of our common practice. If you're interested in that, please reach out. That's another separate topic, but that's the future of meetings. Yeah, there's so much opportunity there. So I guess push the wrong button. Forward. So another big question for me, and this ties in with Sauron and setting up telescopes and managing telescopes, is how do we operate a telescope in the next generation? So this is an image from 1960. It was when the Parkes telescope was sort of, it had been around by now, but it was being operated. This is, I don't know, I think it was 2017, but I guess Richard could correct me. This is an image of what it looks like kind of now in Astron, a lot of screens. Actually, I feel like there's a lot of parallels between these two. And so the question is the future screens? I don't know. But I think what we've seen in CSIRO, at least, the project that we're working on, starting to think about how human knowledge collaborates with machines. And I'm not talking robots, although robots would be really cool, but more about how we work with code, how we work with machine learning, how we work with AI, and what does that look like? And I think that's sort of the revolution we're at with observatories, is really stepping back and saying, okay, how do we incorporate this to our practice? And it's a big change, changing culture too. Also is tied in with the dawn of the mega facilities. There's more than just these three. But on here we have the Square Kilometer Array, which is one of the radio ones, the Giant Magellan Telescope, and the Athena X-ray Observatory. There's more, like for every wavelength, there's probably a couple. So I think the big questions here are, what does this mean for students? If all you ever see are science-ready data products, how are you going to get some of that knowledge that you might need to really understand what's in the data, or ask questions about the data that weren't prescribed in the critical design review 15 years ago? How do we bring up generations of astronomers in this context where they may be segmented into very small parts of that interaction with data flow? So yeah, that's a big question to think about as well, is what mega facilities are going to work for our field. Obviously, we can learn from other scientific fields like physics who have been in this for a little longer, but I don't think anyone's really figured it out. Okay, so to wrap up in terms of what does this mean in terms of advice for career researchers who may be deciding whether laboratory pathways are for them. So one thing I wanted to mention here is, if you are thinking about alternative pathways to academia, observatory is just one, there's lots of other ones, but the best thing to do is to try and learn about potential observatories that could be a good fit for you. So these are some of the things that came to mind. I thought, summer vacation programs actually been for CSIRO, at least, possibly for LOFAR as well, I'm not sure, but these have been a huge way of getting future CSIRO employees into the observatory environment. And astronomers too, a lot of past astronomers were CSIRO vacation students. As I was making this slide, I was like, why don't we do this for PhDs and postdocs? Maybe someone can answer, maybe we do. But I feel like it's an opportunity, to go to an observatory and just work or do a small project sort of goes away. It becomes more informal collaboration, I guess. I wish there were more kind of ways for people to get that experience. Internships or traineeships, so that sort of goes the direction from programs to here. Anyone I could think of that I know of, I think there are some with ESO, but LOFAR Telescope Sciences program, so this was, I forget exactly what they're called, but you can follow the link on this slide later and find out. I'm not sure if they're still doing it. This was a way for people to come and work, I think it was for a couple of months, and get experience with how LOFAR works and telescope operations. In fact, I'm pretty sure Bernard ended up working Astron in LOFAR after that. Anyway, so that's a good way to get some experience directly. Co-supervision programs, so a lot of people can be co-supervised between, say, an observatory project and a university project. That's a really great way to get that kind of experience. You can do postdocs at observatories. These are some of the ones I thought of. There's field research sort of fellowships that sit inside observatories. One's like the one I did at Astron, which was 50-50. So you kind of have a fellowship. It was pretty free what I did with my research, especially if it was aligned with LOFAR and Aperitif. But the telescope support side was determined. To have technical focused postdocs who come in to maybe solve a particular problem or work on something like a global sky model, for example, or you can also have postdocs tied to particular surveys. If the observatory is conducting a big survey as opposed to something that's PI driven, maybe you hire postdocs to come and work specifically on that. So those are some of the ways there. And a good way to see how observatories work is to join time allocation or user committees. So to help just see a bit behind the scenes about how decisions are made about how people observe, also what the observatory is going to do in the future. The other thing I mentioned at the start as well is just contact people at the observatory. And like I said, you can contact me, because I'm happy to be contacted. My breadth of knowledge about some observatories is pretty low. I can point you at other people involved with other observatories. There's space agencies around the world. There are observatories. There are smaller observatories. There are bigger institutes. So, yeah, a lot of different opportunities there. I guess the other thing, and these are where it sort of gets a little bit, I guess, vaguer away from, specifically observatory pathways. But I think as a early career researcher, it's important to be opportunistic about skill development, things that will advance you and build your skill set and make you more valuable on your specific research focus. These are things like workshops and trainings, specifically in the observatory context. These ones are really helpful. They're helpful if you're thinking about industry as well, if you're thinking about going in a more computing or data focused path, but still in academia. I do encourage you, and I guess all your if anyone here's a PhD student, your supervisor is going to be angry with me, but I mean, I think it's really important, and this is true as a postdoc too, to attend and take part in conferences that are beyond your research focus. These are things like AIDA, if that's of interest, or dot astronomy, or I don't know, conferences about discovering the unknown or things like that, because these are the places where you cross paths with people you won't cross paths with at the normal research conference. Also find out about how the challenges you're facing, maybe in black hole mergers, apply to someone who's trying to look at stellar streams coming into the Milky Way. And so I think those conferences and those interactions, whether they be online or in person, really important. And remote participation can be a useful introduction into this, because I'm hoping that we'll see that conferences are more inclusive in the future, which means that if you just want to learn about something, you can potentially participate as a remote person with a very hopefully cheap registration fee about the field, learn who's doing what, and maybe make contact after, without having to physically invest a whole lot of your budget to go to that conference. So I hope that becomes something that's really normalized. Gaining experience with telescopes. If you're part of a big survey project and you're not going to get to observe yourself, you can help, maybe you can propose something on a user-driven telescope. Maybe you can help with someone's observing because they have a lot of observing and they don't want to do it. I mean, take that with a grain of salt, because I feel like hopefully we're just going to automate a lot of scopes in the future too. So maybe there won't be that, but hopefully what we'll see instead is the rise of those internship kind of programs to give people the direct experience of what they're, how it used to work or what skills into making it that way. And I guess a side point is leverage the pandemic disruption. I hope the disruption continues into a sense that it just becomes a disrupted state, but at the moment there's a lot more access to conferences and easier at institutes that you would normally not be able to travel to for a weekly symposium. We have a more digitally connected workforce. It means people are looking outwards and inwards, more willing. If you send an email to someone, maybe more likely to reply. I mean, maybe they're getting more emails, but people I feel like are looking more outwards to global connection right now. Hopefully that stays. But anyway, if you're interested in those kind of questions and how we can change the way astronomy works, then definitely reach out to the Future of Meetings, which is group started having a symposium about these questions, but we've stuck around together because we're still really interested in seeing how we can apply those lessons to our communities. With the button. Okay. And even more broadly, this is a controversial one because ikigai is a Japanese term which means nothing like this at all. It's a Western conception of it, but I actually think this wrong conception of ikigai is really useful. Think about where you might want to end up. It breaks down like kind of things that you could do into 4 categories. So what you really love doing, you're good at doing, what you can get paid for doing, and what the world needs. I think that need can be, in a sense that there's demand for it, but it can also be like need to make the world a better place. So what the world needs may not always interject nicely with what you can be paid for. But anyway, I wanted to mention it because I think the earlier you can be thinking about this and you can constantly be thinking about this, the better chance you have of sort of seeing opportunities as they come up or trying to make your own opportunities as well. And said at the start, astronomy career paths are massive pain, they're stressful, the insecurity of short-term positions and the expectation to move around the world and completely displace yourself from your networks and your friends and your family regular basis in the hope of maybe one day getting a job. These are not necessarily the perks of academic careers. The ways you can sort of work against that is to understand what it is you want, like what's important to you. Do you draw the line? Like, maybe you don't want to leave Europe because of reasons, so that's the limit. Maybe you're willing to work flexible hours, but not in the hours of 2 a.m. and 10 a.m. Like, encourage everyone to sort of think about pros and cons of different pathways and how they balance against your interests. It's also important to be aware of the context of the field. There are such things as hot topics, big projects that have a lot of money, places where the funding is better compared to not. And I think you can be more successful if you sort of are a bit opportunistic about that. If you're in a very, very niche kind of astronomy field, it can be harder because your options may be don't do that astronomy field anymore or move somewhere far away. So these are the sort of things you can think about as well. And so I already mentioned boundaries. Okay, so I'll just leave that there and encourage everyone to sort of think about this adopted version of Ikigai that is still sort of useful in its own way. So in conclusion, I just wanted to conclude by saying that observatory-focused careers and also just non-academic careers, I haven't talked about a lot of other possibilities that are out there, but in the observatory case, they're very diverse and often very cross-disciplinary in nature, I found. I really like that. So it can be a really fitting alternative to traditional academic career paths, depending on balancing those pros and cons for whether it suits you. So I definitely encourage you to more about observatory careers. Reach out if you want. I've put some contact details on the slide here. And thank you very much for listening. These little emojis. Oh, Hannah is flying towards Hannah. I can't hear it. I can.
Great, thanks a lot, Vanessa, for the talk. Yeah, we'll get into the questions now. I don't know if can you see the YouTube chat?
I can, but I'm not sure if I can tell if there's questions there.
Okay, well, we'll just get started while people are thinking about it then. So I had a question actually about the science-ready data products. Maybe if you want to comment, I don't know. I mean, I think it's
sorry.
Yeah.
Camilla?
Can you hear me? Yeah.
someone,
yeah, Hannah?
can we broadcast Camilla? Hang on, let me
I'm
see if I
not
can
sure it's
broadcast
Hannah, but
Camilla.
I think that there's a space for question for the audience if anyone would like to ask. So please be free to do it.
I can't broadcast
Anyone
Camilla.
from
I
the
don't know how
audience
to do
would
it.
like to ask something about it?
Should be broadcasting just by standing on the stage, Hannah.
No, I meant Camilla.
Oh,
Camilla's,
right.
Oh, yeah.
Yeah.
Can you come onto the stage?
These megaphones now.
Try now.
Hi.
Ah, there we go.
Can you hear me?
Yeah.
Okay. So now is the time for questions. Hi, Vanessa.
Hello.
Yeah.
So I guess we're waiting for other questions.
I guess,
raise
yeah.
your
So
hand
I guess
we're going to ask one, right, Hannah?
Yeah, I was just about to
So
ask.
we can wait. I mean, if you want to ask something, it's the time to do it. So,
Camilla,
you know.
can you hear Hannah, by the way? I'm wondering if something strange routing. Can you hear Hannah?
Yes, I'm not sure it's Hannah. Maybe she's taking she's taking a coffee.
Oh, Hannah's sitting next to me.
Okay.
Something's gone weird with the routing.
There's a question in the chat.
Yeah, let's see. I'm going to
What was the
the
most
chat.
difficult moment in your career?
Okay, it was. Yes.
Okay, so
this is the question. What was the most difficult moment in your career? Yeah, from Simca.
I'll start with that question. Camilla, you might want to like reload into alt space just to see if that helps you hear Hannah. So I can hear Hannah. Okay. I'm not sure. Can the stream hear Hannah? See her?
Okay.
Okay, so Most difficult moment in my career. That's a really tricky one because I think there are lots of difficult moments over time. And I think difficult moments and the type of difficult moments change depending on where you're at and what kind of position you're in. Um, so if I think about now, I think one of the difficult things that we have, for example, um, observatories, and I mentioned it on the pros and cons slide, is you never really just do one thing in an observatory. As a person working in observatory, whether you're an engineer or scientist or anything, you usually have a few things going on. And in fact, it's not as an observatory to do that. You don't want to just be doing one thing usually. And so what that means is essentially you end up with lots of competing projects and priorities. So, my focus might be ASCAP, but there's 5 other different projects that different people are assigned to, which also need to happen on specific deadlines. So I think that can be that's one of the really difficult challenges we face right now, that understanding how those competing priorities balance, and where we Eden and Matt and I work at, which is like kind of overseeing the telescope side, necessarily make the decisions about which project the observatory is going to do next. And so I think managing those different competing priorities is one of the really tricky things. And it does, for me, the best solution to it is communication. Transparency in observatories is really important. That has always helped solve things in the past. Before, I think difficult moments, kind of before I was a member, because I do think the nature of it changes. Before I was permanent as an astronomer, before I had like a continuation, it was just constantly stressful because like, I don't know what I'm going to do next. I don't know where I'm going to be in a couple of years. I don't know if I want to keep moving. I don't know if the balance between the passion for the things I'm doing and the enjoyment is worth the disruption. So that was just constantly difficult. And I feel like in the second postdoc, I never really settled. I was just like thinking about that a lot. And the way that helped because it meant I was constantly thinking about having options open. So maybe I would go into industry or I would go into education and just sort of really outward looking in all of the things that were happening. In the end, it did work out, and I am in astronomy, not traditional professor, but more in the observatory, and I really enjoy that. Like that's a super fit for me. But yeah, it was difficult to not have any certainty about where I was going or whether all the things I was doing was going to add up to the end. It's hard. Hannah, did you want to ask your question? I don't think I have another one in the chat yet.
Oh, there's someone in the audience with a question. I'll let them go first and keep mine for later. Okay, let me see.
You can go first and I'll go after you.
Let me see if I can amplify them.
So Elle said you can go first, and
oh, right, okay.
We'll go
okay.
after you.
Okay, right, yeah. So I obviously had a question about the science-ready data products, which I guess also ties into this idea of
But
automation.
from the live stream,
so automating
I can
both
see Hannah.
I'm gonna
So
mute
Hannah-
Camilla for a second.
Okay.
All right, go for it, Hannah. Sorry.
Yeah, so I guess it ties into this idea of automation. So automating not only the actual telescope observations, but also the whole pipeline of reducing the data and calibrating it, and then delivering these sort of calibrated data products to people. I mean, it does really take out the almost the need for people to understand, how the sausage was made, and how it came to be, and really understanding the nature of the data. And so I think that's a bit of a concern, really, because I mean, it really sort of starts to limit how the science, how we can, sort of progress the science in it if you don't really understand the data. It's really a sort of a fundamental limit to how we can progress the science. So I don't know, I mean, do you think that the way forward is to try and have these sort of workshops where people can try and do the data reduction themselves? I mean, what is the strategy, do you think? Especially with these telescopes.
They're
ALMA
really-
and so many users of the data. Like it used to be quite a narrow field, radio astronomy, and now with telescopes like ALMA, it's not so narrow anymore. It's pretty widespread.
No, so that is a really important question, and something I think is far from solved at all in astronomy. Because at the moment, there's a kind of thought pattern that says, okay, well, it's fine. We don't need astronomers to understand the data anymore because they'll all be automated and it's fine. Then you have to say, okay, well, we're still riding the wave of supervisors and the senior leaders in our field. They all had that experience, right? What happens when you have a whole generation of people come through who have never used a telescope, who have never reduced a single data set? What happens when they have to then design the next telescope? And I think there's a way in which you can't infinitely niche away. You can't just completely take away astronomers from the data. I don't think workshops are going to do it, honestly, because I did school, I did workshops, and that's not where I got my knowledge. Like, it's where I got some of the knowledge that helps with observatory, but it's not where all of it from. It's from just like sustained interaction or trying to solve problems. I think what will maybe a good path is that there'll be different kinds of career pathways for people. Maybe you'll be able to have those kind of experiences to an observatory through maybe you do a PhD that's half observatory based and half academic, and it's like very technical. I don't think it's a problem, but I definitely share the concern of people going to get that expertise in the future. I don't think it's solved at all.
Okay. Any questions?
Yes.
I think there was, yeah.
Yep.
It was Al. I don't
mentioned earlier.
I have the ability to magnify people, I'm sorry.
Oh.
I've amplified.
Okay, great.
You mentioned earlier about having lots of different roles. That's quite unusual compared to a standard academic researcher, where typically you research black holes or you research, about to say AGN, that's basically the same thing, but you have a very specific. Have you ever found that difficult when describing what you do for your job, or maybe when thinking about a future move? Like, how do you describe your job to other people?
Yeah, that's a really good point too. I think in some ways, if you're in a traditional stuff, you also have many hats. You know, like you could be anything from you may be a grant writer, or maybe you have to write grants at some point. And you have to manage people or supervise people. That's true in what I do as well. I think it has been hard, and I also felt it was difficult as when I was more in the research world because I wasn't a world expert in black hole edges or anything, right? Like I did lots of different kinds of science because I thought it was more the data and the questions were interesting than the very specific science question. That's sort of a personal preference. Some people really like to go into detail deeply on something to solve a really hard problem. Thought, well, so many interesting problems, just put me in a direction of a cool one. But that was hard actually because I did get advice as a research postdoc, you know, like you have to be the world expert in this thing so people know to come to you and you establish that reputation. Now I think it sort of works more in favor. I think that I don't know. If you look at industry, for example, they tend to box people a bit more. It's definitely harder to say, okay, this is what I do. An observatory, what would I do? But I think it at least it opens up a lot of different opportunities in my experience because the automation side mixes in with stuff that's happening in CSIRO in mining. Talk about Sauron, you know, we link in with the cooperative intelligence people thinking about all of these problems in different science disciplines. In my experience, it hasn't been a barrier, but I also have I do have trouble saying what I do. It's not a one sentence thing. Yeah, mostly good, but can be tricky. I'll check. I think I
There's
can
no more in the
see
chat.
more questions on the live stream.
Is there any more questions from the audience or from the live stream chat? Okay, well, if there's not, we can end here. But I think as Vanessa said, you can probably access her via the IAU Junior Members Slack if you have any questions you want to ask her there. And meanwhile, we can, anyone who's in the alt space, we can go and explore the alt space together. If you want to stick around, have a chat, we'll hang around for a bit. Thanks everyone for coming. Thanks again to Vanessa for the lovely talk. See you for the next talk.
Thanks, everyone. Thanks for having me.
I think it's okay, no? Anyone has more questions, or I think the time is already done. So
Yep.
I don't know.
We are live now.
There is a final chat question.
What is it?
That is, how difficult is it for researchers working on data analysis or theory to shift to the observatory-focused career?
That's a good question. I think data analysis is a lot. It depends a little bit on the skills and the kind of observatory career you would go after. But yeah, I mean, I think it really just comes down to interest and skill sets and sort of being connected with the direction you might want to go to an observatory focused career. I think if you're applying for a job that is, it's going to ask you what is your experience with observational facilities. It's harder. And so to give yourself a good chance of that, I would definitely try to build up that experience with, hands-on observational data skills. Being a theorist doesn't preclude you from developing those skills as well. I think it kind of fits into the opportunistic skill development to give yourself the best chance if that's the direction you want to go in.
I'll just check with the stream, with the chat, see if there's any other final questions, because they are running 20 seconds behind us.
I can always go back and answer in the chat too.
Yeah, I mean, we can always carry on the discussion in Slack as well. If those people want to ask in Slack. Join our Slack, by the way. If you're not on Slack, you can always join. Just email iaujuniormembers@gmail.com and we will get you into the Slack. All right.
In alt space.
All right,
I don't know where to
great.
look anymore.